Hello guys. Today's class we'll be taking the reduction formula. Now look at the above questions. The question says evaluate integral sine raised to power nx dx. Hence solve integral sine raised to power 5x dx. Firstly, reduction formula makes it very easier for us to integrate trigonometric functions of raised to power. You get what I'm trying to say? So if you can get a reduction formula for sine raised to power nx, then there is no question on trig function of sine with power that you won't be able to solve. Are you with me? So firstly, to integrate this, I can say let the question which is integral n raised to power nx dx, let it be I of n, which is the same thing as integral sine raised to power nx dx. Okay, so I of n is equal to integral sine raised to power nx dx, which is the same thing as law of indices. I can split it out by saying it's the same thing as sine raised to power n minus 1x sine x dx. If you apply law of indices to this, you have this back. So why I express it in this form is so that I'll be able to apply integration by part. So by integration by part, I'll be having it to be, if I apply integration by part, this will be my u, this will be my dv. So integration by part, I'll be having u integral dv with respect to x minus integral into bracket integral dv, then d dx into bracket sine n minus 1x. So that's integration by parts. So if I split it out by solving, I have it to be sine raised to power n minus 1x. If I integrate sine x, I have minus cos x minus integral. If I integrate sine x, I have minus cos x times, if I differentiate this, I have n minus 1 sine n minus 2x cos x dx. Are you with me? So from here, I can say it's the same thing as minus sine n minus 1x cos x. Bringing out the constant, I have plus this minus this is a constant, n minus 1 integral sine n minus 2x cos square x. How did I get cos square x? This multiplied by this, I have cos square x dx. So looking at it, this is basic identity, which is sine square x plus cos square x is equal to 1. So I can make cos square x the subject of the formula. I'll be having minus sine n minus 1x cos x plus n minus 1 integral sine n minus 2x into bracket 1 minus sine square x dx. So if I expand the bracket, I'll be having minus sine n minus 1x cos x plus, when you expand this bracket, you end up having n minus 1 integral sine n minus 2x minus n minus 1 integral sine nx dx. But don't forget, what we are solving is I of n. Are you with me? So I can say, since the question integral this is I of n, then I can say I of n is equal to minus sine n minus 1x cos x plus n minus 1 into bracket I of n minus 2 minus n minus 1 into bracket I of n. By collecting like terms, if I take this to the other side, then I end up having 1 plus n minus 1 I of n is equal to minus sine n minus 1x cos x plus n minus 1 I of n minus 2. So I have it to be n I of n equals minus sine raised to power n minus 1x cos x plus n minus 1 I of n minus 2. Therefore, if I make I of n the subject of the formula, which is our initial question, then is equal to 1 over n into bracket minus sine n minus 1x cos x plus n minus 1 I of n minus 2. Final answer. So the reduction formula for integral sine raised to power nx is the same thing as 1 over n into minus sine n minus 1 x cos x plus n minus 1 I of n minus 2. So initially we are asked to evaluate. After evaluating, then hence solve this. So let's try to solve this using the reduction formula. So to solve this, I will say integral sine raised to power 5x dx. By comparison to the initial question, n is 5, right? So I can say it's the same thing as I of 5. So by comparison, since it is the same thing as I of 5, then automatically my n is 5. So I can say I of 5 is equal to 1 over 5, meaning in this reduction formula, anywhere I see n, I put 5 into bracket minus sine 4x cos x plus 4I of 3. This is my answer. But in the answer, I have I of 3, so I can evaluate I of 3. Then I of 3 will be 1 over 3 into bracket minus sine square x cos x plus 2I of 1. I can still evaluate I of 1. So if I evaluate I of 1 will be the same thing as integral sine 1x, which is the same thing as integral sine x, which is minus cos x. Therefore, I of 5 is equal to 1 over 5 into bracket minus sine 4x cos x plus 4 in, what is I of 3? 1 over 3 into minus sine square x cos x plus 2 of I of 1 minus cos x. So if I expand the bracket, 1 over 5 will multiply everything. So 1 over 5 times this, I'll be having I of 5 to be equal to 1 minus 1 over 5 sine raised to power 4x cos x. 1 over 5 times 4, that's 4 over 5, times 1 over 3, that's 4 over 15, times this, minus 4 over 15 sine square x cos x minus 1 over 5 times 4 times this, that's 4 over 15 times 2, 8 over 15 cos x. Therefore, the integral of sine raised to power 5x dx is the same thing as this from reduction formula. Thank you. So since you've been able to solve reduction formula of sine raised to power nx. So with the knowledge of sine raised to power nx, you are going to solve integral cos raised to power nx. So based on the same idea, you'll be able to evaluate question on it. So on your own, you can try integral of cos raised to power nx dx. Thank you.